Okay, so that is started. Because sharing कुछ stop हो रही है. Word, yes, this one. Okay, so that can decay into photon, and normally the lifetime for this kind of decay is 10 to the power of minus 22 to 23. This is the time scale in seconds. And when it is doing a electromagnetic interaction, this is electromagnetic interaction where photon is involved. So this is electromagnetic interaction. So this will take around 10 to the minus 16 to 10 to the power minus 18 seconds. So that is a bit slower than this one. And it can also decay into leptons. This is leptons, and this is a weak interaction. Weak interaction. So this will take around 10 to the power of minus 8 to minus 10 seconds. Okay, so they decay into all the three kind of different particles. So meson में decay हो रहा है, heavy meson can do in the lighter meson, a meson can decay into a photon or gamma radiation, or meson can decay into several leptons also. So meson can follow all the three kind of interactions. जरूरी नहीं है कि it is only following the strong interaction. Though it exists in the nucleus, but within the nucleus it do strong interaction. But if it is generated in any accelerator or reactor, if it is generated, then it can do other things also. Means it can do electromagnetic interaction, it can do a weak interaction also, and their lifetime is this one. The slowest is the weak interaction, midway it is a electromagnetic, and when it is somewhere here it is a strong interaction. This time is very important, and you can calculate. This is a time scale. You can calculate the light, how much a photon or how much means this light quanta can travel what distance within this time. That you can do the calculation. That is your homework कि भाई इतने टाइम में लाइट कितना ट्रैवल करता है, और उसका जो डिस्टेंस है वो किसके कंपेरेबल है, न्यूक्लियस के कंपेरेबल है या एटम के कंपेरेबल है या प्रोटॉन के कंपेरेबल है. प्रोटॉन का भी मैंने साइज आपको दिया है, तो यू कैन कैलकुलेट दिस टाइम. So this is a very important time, and you will understand why this very small time, or we cannot go further, or we just you do the calculation, then you can understand what I'm saying कि पहले एक टाइम के हिसाब से डिस्टेंस निकालो कि एक लाइट कितना ट्रैवल कर सकता है डिस्टेंस. व्हाट वी नो, सन से अर्थ तक हमारा डिस्टेंस कितना होता है. डिस्टेंस अगर नहीं भी पता है तो लाइट का अगर स्पीड पता है आपको कि व्हाट इज द स्पीड ऑफ लाइट, एंड यू कैन मल्टीप्लाई विथ कि आपको यूजुअली पता है कि 8 मिनट्स रफली लगते हैं, 8 मिनट सम सेकंड्स है, 8 मिनट्स में वो कितना डिस्टेंस वो ट्रैवल कर सकता है. यू कैन इजीली कैलकुलेट दैट पर्टिकुलर डिस्टेंस कि सन और अर्थ के बीच में सेंटर टू सेंटर क्या डिस्टेंस है, या सरफेस से भी अगर आ रहा है तो कितना डिस्टेंस पे वो कवर कर रहा है. बट we don't have these kind of interactions only. Mesons also do a certain other kind of interaction, which is unusual, which is not usual, which I have discussed with you somewhere when we are discussing the bubble chamber. तो bubble chamber में मैंने आपको एक picture बनाया होगा, something like this one. Somewhere in the bubble chamber, a particle, means the bombardment of the particle is done here. Okay, and shower of particle has been emitted from this point. So कुछ इधर जा रहे हैं, कुछ यहाँ जा रहे हैं, कुछ राउंड होके इधर गए, फिर कुछ राउंड होके गए, कुछ स्ट्रेट चले गए. Somewhere they are moving, and we can measure these particles. उनके charges measure कर सकते हैं because we have applied the magnetic field. We can measure the electric charges, we can measure the masses, and we can measure several things. Spin वगैरह सब कुछ निकाल सकते हैं. But sometime what we see कि हमारा जो center है, from the center, after certain distance, a particle has appeared, and then it do a decay. After certain distance, means from the center where the bombardment has been taken place, we don't know what is here. Something is missing. Means our detector, whatever the detector you have placed, that can be a electrostatic detector, that can be a light detector, that can be a magnetic detector, that can be a gas kind of detector. So whatever the detector you have placed, it has not capable to measure this or able to detect this particle. It is there because if some particle has moved from this to this distance and after that it has appeared and it decayed into two different particles. Normally they do in the pair. अगर ये इधर एक particle गया तो दूसरा भी इधर आएगा. Normally we have V shape in two pairs form or 4 or 6 or something like that. They always in the pair. So due to these unusual behavior and some other unusual behavior also, we have to define new kind of particle. Mesons ये तीनों तो हमें मिल गए, ये तीनों हमारे ये जितने भी पार्टिकल आपको दिख रहे हैं, कुछ स्ट्रेट जा रहे हैं, कुछ सर्कल में जा रहे हैं, so they can be classified under this particular category. And power has gone in my home. अभी तक तो चल रहा है कंप्यूटर, अगर कंप्यूटर बंद हो जाता है I will again join and message you. अभी तो चल रहा है. So these particles, they form these interaction are usual interaction, but sometimes it happens a different kind of interaction which is not explainable easily what we know till now. So they have been classified into another category. Means they have been classified into another category. So what kind of those category are? So they are charm, they are bottomness, this is double T, there is topness, and there is truth. And obviously we have a strange also. So these different kind of new category, because Meson don't only follow these in a usual way, but they do different kind of interaction also. And that interaction you cannot explain easily. And how that has happened, we don't know. We have to define a new quantum number. So these new quantum number has been defined, or you can say new properties has been defined. So this is something like a strange. You don't know anything what is happening here, and someone has appeared somewhere here, and it has decayed into two particles. So this is something like a strange. Similarly, similar kind of unusual behavior that give rise to charmness, bottomness, topness, and truthness. And we also have normal, means normal understanding, normal usual behavior. They are done by the up and down quark. अप एंड डाउन क्वार्क तो हमारे पास पहले से ही है, जो कि यूजुअल बिहेवियर जो ये कर रहे हैं, बट बाकी जो अनयूजुअल बिहेवियर दैट इज डन बाय दीस क्वार्क. सो वी थिंक कि mesons are not only made up of up and down quark, but they are made up of these kind of quark also, and we have to define a new property. We cannot just classify under these two categories. We have to define, because they are not behaving in a similar way as the up and down are doing. So we have defined these kind of category. So let me give you certain example which mesons are something like this one. That is, there is a K meson. K has all the charges, plus, minus, K0 is there, K star is there, which is plus charge, but something different from this particular K plus, and K0 and star is also there, which is different from this one. We will see what is the difference between these two things, and we will see in the later. So these are strange. Someone asked, give me example of a strange meson. So they are K particles. Then we have D particles, which is D plus minus D0. And again, we have D star and plus, we have D star and 0. They are charm. So they are charm mesons. तो charm meson का example क्या है? D. अगर exam में भी कहीं आता है कि give one example of strange meson, give one example of charm, and give one example of bottomness. So you can write these. Then we have B plus and B0. They are bottomness. And then we have F particle, and this F particle is strange and charm both. Means they behave in both the way. So these are the examples, and pi और बाकी जो examples हैं वो normal quark के हैं, which is you have pi, you have rho, you have omega, you have eta, and you have eta dash, and some more are there. So these are usual, which is made up of up and down quark. But when you see these kind of particles, if you get this kind of particle detected in a detector by your whatever the experiment which you have done, so they are coming from the strange, charm, bottomness, and something like this one. But they don't have lifetime. Their lifetime is very small. Obviously, you have to detect in an indirect way, or somewhere you have to be a very faster way you have to detect these particles. They are not normal occurring particle. Okay, so normal हमेशा normal वाले ही रहेंगे, up and down quark ही रहेंगे. तो ये सारे unusual हैं, तो they don't have the lifetime also. Their lifetime is very small. Then we come to the baryons. The second category है, that is baryon, and then we will go to the this conservation law. Okay, so the baryon, in the baryon, again we have different kind of categories. Normally there is spin, or you can say the spin of the particle, integral spin of integer spin of the particle is not there half integral particles. Obviously they are fermions. यहाँ पे जो cases थे इनमें हमारे पास spin की value 1 की possibility है, +1, -1 and 0 की possibility. 0 की भी range बहुत कम है, but we have the possibility of these numbers as a spin. But in this case, all the baryons are half integral. They cannot be integral spin. So either they can be half, they can be 3/2, or they can be 5/2, but we have no particle which is having 5/2. Still, it is not detected. So we only have these two. तो ये तो half है या 3/2 है spin. और half or is 3/2 का meaning क्या हुआ? You can go with -3/2 to 3/2 with 1 unit change, or you can go -half to half with 1 unit change. These minus sign is just like a projection when you do the experiment in a z-axis. You can assume कि हमने पहले भी discuss किया था ये half कहाँ से आता है? जो magnitude है that is half and 3/2, but minus sign क्या आता है? It can be aligned in along your direction. It can to your whatever the experimental axis you have took. तो दोनों के केसेस में माइनस और प्लस का वैल्यू आ जाता है, फिर बीच में और वैल्यू आ सकते हैं, दैट इज -half, और यहाँ पे +half आ सकता है. तो you can have these kind of orientation that is concerned with the orientation, and obviously the particle wave function will be different, and if the wave function is different you can say that is a new particle. तो कई बार ये भी होता है कि वेव फंक्शन अगर चेंज हो गया तो हम पार्टिकल को नया पार्टिकल भी कह देते हैं, which is something like a resonance. तो resonance जो हमने लास्ट टाइम भी डिस्कस किया था, that resonance exists in these particles. Pi resonate करके it can become omega. The particle is same, but its energy and mass is different, so that is a new particle. So just hold on just a second. So all the baryon will follow the strong interaction. They will follow the strong interaction. जितने भी baryons है nature में, they will follow the strong interaction. They don't follow weak interaction. They can decay, means when a baryon is interacting with a baryon, that will do in the strong interaction manner. But a baryon can decay into some other particle, for example, neutron. Neutron can decay into a proton. It is not doing interaction, but it is decaying into a proton, and at that time it can do intermediate or weak interaction. But most of the time they follow the strong interaction. The lightest member means सबसे जिनका weight या mass which is lowest in the set of baryons, that is actually the neutron and proton. So they are the lightest member. You can say the first generation of baryon is neutron and proton. So they are the first generation of baryon. Then you can have furthermore which is delta particle. Delta particle, they have 2 plus charge, they have delta plus, they have delta 0, and they have delta minus also. So there is a 4 different category of delta particle. This is a first generation, you can say, and then heaviness is this one. And then after these two, you have different baryons, which is concerned with the strangeness, charmness, bottomness, and so many. Means you can write millions of particles. There is so much combination is possible. कोई दिक्कत नहीं है. आपके पास 3 set of quarks हैं. उन तीनों क्वार्क के आपके पास 6 कैटेगरीज हैं. 6 कैटेगरीज में भी आपके पास different color है, and you can make several combination. But only problem is that can it be verified? Can it be measured? This is the problem, because this is the lightest member, and as you go on heaviness, their lifetime is going to decrease. So न्यूट्रॉन प्रोटॉन को छोड़ करके बाकी सारे बेरियन सिर्फ आपके एक्सेलरेटर में ही जनरेट होते हैं. At high energy they can generate it. You don't have a means they're not found anywhere in the nature. आपको उसे जनरेट ही करना पड़ता है. और जनरेशन इज समथिंग लाइक कि मींस यू डू द एक्सपेरिमेंट कंसर्न विद द nucleon interaction. So when you do the bombardment of nucleon, then you can find these particles, and there is a possibility. So बहुत सारे particle है. अगर लिखना हो जाओ तो 100, 200, 300 जितने भी लिख सकते हो, you can write that. There is a possibility of combination. So there is no restriction on that. Okay. So we have neutron proton is the lightest, then heavy is the delta, and we have one more particle which is very unusual, that is omega. Omega ऊपर कहीं नहीं था. Omega is having all the 3 quark, which is strange quark. यहाँ पे साइड में suffix लिख रहा हूँ. Suffix का meaning है these quark are strange. So this is a completely strange particle. In nature, omega is completely strange particle. All the three quark are strange quark. But these delta may have some kind of strange. These are actually normal. These two are normal. Then we have epsilon. Then we have this. I don't know the symbol. What the symbol is. Name is different. The symbol is this one. What the symbol is? It is. I think it is capital theta. You can say. और मेरे को देखना पड़ेगा सिंबल का नाम क्या है ग्रीक में. This is summation. So summation we have. This particular particle we have, this is existing in plus minus and 0. This is also in plus minus. I think this is in plus minus only, or maybe something which is 0 also. I have to check that also. So this is in plus minus 0 also. And then you have the this. So there are so many lists. So आपको ध्यान रखने की जरूरत नहीं है. आपको सिर्फ इतना ध्यान रखना है. Mostly interact through strong interaction. They have half integral spin, and they are made up of 3 set of quark. This is what 3 things you have to remember. So baryons are having half integral spin. They are mostly doing a strong interaction. Hardly they follow the weak interaction or electromagnetic interaction. That is not dominating actually, not dominating. The strong is dominating for them. And then they are made up of 3 set of quarks. That quark can be anything. Means 1 is up, 2 is down, 1 is up, 1 is strange, 1 is down. You can have several kind of combination. So 3 quark which is making up the baryon. And when someone asks you to differentiate between these two, you can easily differentiate. They have integral spin, they have half integral spin. They are made up of quark and anti-quark pair. They are made up of 3 quark, and they are in way they are lighter than the baryon. And you can say the baryon is heavier than the mesons. And mesons can follow all the 3 kind of interaction, but baryon only follow mostly they follow the strong interaction. Okay, so these are the few difference you can say in terms of if जो question come कि भाई differentiate करो mesons और baryons को. और लेप्टॉन को तो कर ही सकते हो. लेप्टॉन को अगर डिफरेंशिएशन आता तो दैट यू कैन डू इजीली. लेप्टॉन्स के मैंने आपको बहुत सारी प्रॉपर्टीज दे दी हैं. यू कैन कंपेयर देम विद द हाइड्रॉन्स आल्सो. सो इन पार्टिकल्स के बहुत सारे चीजों मतलब बहुत सारी डिटेल में जाने से बेटर है वी जस्ट गो टू द कंजर्वेशन लॉ व्हिच इज यूजुअली कम इन द एग्जाम कि भाई कंजर्वेशन लॉ को यूज करके you have to judge whether the reaction is going to happen or it is not going to happen. Okay, so these are the classification. So I have given you how many classification. We have field particles, we have leptons, we have mesons, and we have baryons. That's all. We don't have any other particle. और कोई क्लास नहीं है हमारे पास, सिर्फ इतना ही है. We have 4 different category. 4 different category में भी हमारा जो last category था वो हाइड्रॉन की कैटेगरी में आ रहा है. Means these both can be kept in a hadron kind of category. So we have only have a broader way, you can say we have only of 3 set of particles. One is field carrying particle, which is actually sometimes it is called as virtual particle. Then we have lepton, which is a real particle which exists in nature, and we have a hadrons which also exist in nature. But in nature, only the lightest member have a longer lifetime. All other heavy member have a shorter lifetime. So how many particle you have counted which make up the matter? अभी तक कितने पार्टिकल आपने काउंट किए? अगर यही 3-4 पार्टिकल है, इससे ज्यादा और कोई क्लासिफिकेशन है नहीं हमारे पास. तो नेचर को बनाने के लिए कितने पार्टिकल्स हैं? We have a lightest hadron, or you can say lightest baryon. We have the lightest lepton, and we have force carrying particle. That's all which make up the matter. But still, the baryon is not an elementary particle because they are made up of certain other particles. They are composite particle kind of system. So we have to find how many those are, means how many quark are there. And मुझे लगता है यहाँ से मेरा UPS भी बंद होने वाला है, तो I will join again and give you the message in the this WhatsApp कि कब दोबारा ज्वाइन करना है, क्योंकि अभी लाइट नहीं है, so we cannot continue that. Okay, तो एक बार जरा पावर जाने ही वाला है मेरा, तो बस UPS is beeping up very
Yes,
fast.
sir.
I will message you in the WhatsApp group. Okay, so then you can join.